Good morning, everyone. Okay, we may start now. Okay, so today we are going to discuss the last part of this chapter. Okay, so far we are on track. I mean, we are following the weekly schedule. So that's a good thing lah. Okay, so hopefully, okay. Apa saya nak cakap tadi? Apa? Okay, we are on the right track lah. Okay, so insyaAllah, in terms of syllabus, we are ready for test 1. Okay, normally test 1 will be up to LU, okay, up to LU method, okay, meaning that this part, the 2.5 in your lecture notes here, normally is not included in test 1. Okay, but then I will update, okay, from time to time if we have any changes lah in this semester. Alright, so 2.4 iterative method. We have two methods in this part. The first one is Jacobi, second one is Gauss-Seidel. Okay, Gauss-Seidel method. As the name of this subtopic, which is iterative, okay, so we can expect in along the process in the calculation we are repeating the same process. Okay, iterative, just like what you have done in chapter 1. Okay, chapter 1 you have 3 methods tu, semua itu adalah iterative. Okay, so when we are talking about iterative method, first we need to have the initial guess or initial value, and we also need to have stopping condition. Okay, because you are doing, you are repeating the process. Have method, two possibilities of our solutions, either converge or diverge. Okay, so to make sure that our solutions, okay, will be converged, okay, to the solution that we aim to have. Okay, so we need to have the what we call the convergence criteria. Okay, so if you can recall in chapter 1, okay, you have the fixed point iteration method. Okay, you have convergence criteria for that method. Okay, but now for the iterative method in chapter 2 for Jacobi and Gauss-Seidel, it is something else. Okay, the convergence criteria, but the criteria for that convergence is different. Okay. So criteria said that A, which is our coefficient matrix, okay, A must be strictly diagonally dominant. Okay, in short, we can put we can have SDD. We can write as SDD, strictly diagonally dominant. Okay, so this is the definition, okay, of SDD. A matrix A is strictly diagonally dominant if, okay, you can see the absolute value, okay, the absolute value, the positive value of AII. Okay, so if we have 3 by 3 system, for example, then AII, okay, will be referred to A11, A22, and A33. So you know that AII is basically your main diagonal. Okay, the main diagonal at each row should be greater than. Okay, so we have the greater than here, and then we have the summation. Okay, the summation of the absolute of AIJ. Okay, meaning that for row number 1, you are going to have A11. Okay, row number 1. So the main diagonal is A11. Must be greater than, okay, in terms of absolute value, must be greater than the summation of A1, 2, okay, plus A1, 3. If we have 3 by 3 system. Okay, if you have 4 by 4, then you have one more plus A1, 4. That's on rule number 1. Okay, so for rule number 2, the AII is going to be A22 lah. Okay, must be greater than the rest of the elements on that row. Okay, so we have the modulus or the absolute of A21 plus A23. You don't have A22 at the right, okay, because J cannot be I. Okay, so basically the A22 is at the left hand side. Okay, and then for third row, the main diagonal, the AII is the A33. Must be greater than, so on third row we have A31, we have A32. That's it. Very simple. Okay. The proof, or how do you verify whether your A is strictly diagonally dominant, is very simple. Not as much as what you have in Koleski. Kan? Koleski you have SPD, symmetric positive definite. You have 5 criteria that you need to fulfill. But for SDD, it's very simple. Okay. Okay. So in the problem, you might have matrix A which is not SDD initially, okay, but you need to try to rearrange, okay, the rows if possible. Okay, if it's possible, then yeah, it should become the SDD matrix. Otherwise, yeah, if you cannot form the SDD, meaning that okay, you cannot use the Jacobi or Gauss-Seidel. Okay, because if you still proceed with the Jacobi and Gauss-Seidel, you will end up with a diverge situation. Okay, you will not get your answer at the end. Okay, so for the Jacobi and Gauss-Seidel, first of all, you need to check for SDD. Okay, strictly diagonally dominant. Okay, take the simple example here, example 16. I think I just read through here. Show that this matrix, so this is your matrix A, is an SDD matrix. Okay, so the solution. So you look at row number 1. At row number 1, the main diagonal is 3. Okay, so A11. So the absolute of 3 must be greater than the summation of the other elements on row number 1. Okay, in terms of absolute value. So you have 2 plus 0. So 3 is greater than 2. Okay, so we can check on that. Okay, so we satisfy the SDD. Okay, but for row number 2, okay, we need to check row by row. Tak boleh satu saja. Okay, each row. So row number 2, the main diagonal, diagonal elements is -5. Okay, but we look for positive value. So the positive 5 must be greater than, okay, this one, 2 plus 1. Okay, so 5 greater than 3. So we are okay with that. And lastly, row number 3, the diagonal elements is 7. Okay, so 7 must be greater than 1 plus 2. Okay, so 7 greater than 3. So we satisfy the condition for the SDD, each row. So we can conclude the above matrix is strictly diagonally dominant. Clear? Simple je dia punya proving dia. If you do not satisfy maybe one of the rows, then your conclusion A is not SDD, even though only one row that is not satisfied. Okay. Okay, now go to the first method in this part, the Jacobi. So if we have a system, okay, I'm going to have, you can to your notes while I'm jot down here. Okay, so let's say you have a system, general system, A11 x1, okay, plus A12 x2 plus A13 x3 equals B1. Okay, the general form. Okay, so first of all, we need to construct the formula for our x1, x2, and x3. Okay, so in the second row, you have a21 x1 plus a22 x2 plus a23 x3. Okay, so we take 3 by 3, okay, for illustration. A31. Okay, so this is the form. This is the linear system after you have verified that your A is an SDD matrix. Okay, so A is supposed to be SDD. Okay, in this case. All right, so to form our X1 formula, so basically we refer to the first equation 1. Okay, so you refer to the equation 1 to form the formula for x1. Okay, so by that equation, rule number 1, so x1 is b1 minus a12 x2 minus a13 x3 over the coefficient of x1, which is a11. Okay, so that's how you get the first formula. Okay, but then since this is iteration, so we put the iteration notation. So we put here k plus 1. At the right hand side, all the x are at stage or the previous iteration. Okay, so first of all, you will be given the initial value, meaning that you know x1 naught, x2 naught, x3 naught. Okay, so in the first iteration, you are going to have your x1 1 at iteration 1. You are going to have x1, okay, 1, okay, at the top. Okay, so you always start with a k equal to 0. Okay, so I put here x1 0, x2 0, x3 0 will be given or should be known. Okay, that's formula for the x1. Okay, formula for the x2 comes from equation 2. So you form formula x2 from equation 2. Okay, so this one formula for x1. Okay, and accordingly for x3. Okay, so that's how you get all the 3 formulas that you can see in the lecture notes too. Okay, so you have b2 minus a21 x1 minus a23 x3 over the coefficient of x2 is a22, and then you just put the iteration notation k at the left, k plus 1. Okay, so similarly for the x3, it comes from formula equation number 3. Okay, so okay, so that's how you get the x1 here, x2, and also the x3. Okay, with the initial guess, this one, okay, again, this one should be known. Just refer to the problem. And then the stopping condition. Stop the iteration process when, so this is the notation for the stopping condition, the max, okay, max. So in the bracket here, you can see the absolute value, xik minus xik minus 1. Meaning the difference between 2 consecutive x. Okay, so later in your calculation, you are going to have the value for x1, x2, x3. Okay, so the max, so at each iteration, you are going to compute x1 minus x1. So this one at the previous iteration, this is the current iteration. Or I can have k here. And okay, can have here k. This one is k minus 1. Or you can have k plus 1 minus k. Okay, the same meaning. And then we have the absolute of x2 minus x2. This is k minus 1, comma. you're going to have x3 minus x3, current iteration, previous iteration. Okay, so at each iteration, you are going to have values of x1, x2, and x3. Okay, so to decide whether you need to stop or not, it actually depends on the difference between two consecutive x for each x that you have. Okay, so let's say in your iteration, okay, the difference between two consecutive of x1, let's say you have 0.01. Okay, in terms of absolute value, and this is 0.02. Okay, the difference between x2, current minus previous, and somewhere here you have 0.06, for example. Okay, and let's say the question asks you to stop when x I minus xi. Okay, this one in terms of vector. Okay, if you have something like this in your problem, okay, let's say this is given by the problem. Stop when you satisfy that condition. Okay, so back to this. So the maximum out of 0.03, 0.02, 0.06 is, max is 0.06, right? Among those three. So this value still greater than 0.05. So meaning that you need to proceed. You cannot stop yet. Okay, even though the difference between two consecutive x1 is already less than 0.05, the difference between two consecutive of x2 already satisfy the stopping condition, but the third one is still greater than 0.05. Okay, so you look for the maximum. Okay, the maximum of error of x1, x2, and x3. Okay, if that maximum value is less than the given epsilon, then you may stop. Otherwise, you still need to proceed. Okay, faham tu Clear? And the stopping condition. Okay, so this is what it means by max and everything that you have here. Okay, and lastly, you take your final answer because our intention is to have the value of x1, x2, and x3. Okay, so the final answer should be the latest x that you have in your solutions. Okay, okay, right. Let's look at example 17 here to illustrate how we use all the formula and apply the stopping condition and whatnot. Okay. Okay, solve the following linear system using Jacobi method. So first thing first is to ask whether A is strictly diagonally dominant. Yes or no? So is A, okay, SDD matrix? Anyone? You take out your A?
No.
No. Okay, correct. No. Because your A, if you take out this, your A is 1, -3, 12. So on the first row, it is already obvious. So the A11 should be greater than the summation of 3 and 12, which is not true in this case. Okay, so initially it is not. Okay, it's not an SDD matrix. So I can say initially it is not. Okay, try to rearrange. Try to rearrange your system, your equations, meaning that you need to think of swapping. Okay, swapping here and there, swap rows here and there, so that you can come out with A that is SDD matrix, strictly diagonally dominant. Okay, so basically you look for in each equation that you have, you look for the greatest value, get the largest value. For example, in equation 1 here, the largest would be 12. Okay, so 12, if you think of the summation, is greater than -3. Okay, in terms of absolute value, so it is 3 plus 1. Okay, so 12 is at third column, so most likely it will be on the third row lah. Okay. And for second equation, you can see the largest coefficient is 4. Okay. So 4 greater than 1 plus 1. So 4 is at column number 1. So it will go to row number 1. Okay. And for equation number 3, the largest coefficient is 7, which is at column number 2. So it will go to second row. Okay. So that's how you rearrange, okay, your rows. Right. So the new A should be for 1, negative 1, which is your equation 2. Then you have 2, 7, 1, okay, equation 3, and then 1, negative 3, and 12. Right. Okay. But when you change rows here, don't forget B also need to be swapped. Okay. So B, so you take for 1 negative. So 3 and then 2, 7 is 19 and then 31. Okay, so change your B as well. Okay, otherwise you get wrong answer. Alright. Okay, clear on the SDD. Only then we can proceed with the formula. Okay, we can proceed with the formula. So I'm going to put here. Okay, formula. So first, checking for the SDD. Number 2, form the formula. X1. Okay, so to form your X1, you look at the latest A and B. Okay, so you ignore the original problem because this one is not SDD. Okay, so you refer to 4, 1, negative 1, and 3 for the first equation. Okay, so on for the second equation and third equation. Okay, so you put X1 at the left with the iteration notation K plus 1. Okay, at the right hand side, okay, so from equation number 1, I know that I can read as 4x1 again plus x2 minus x3 equals 3. Okay, so I take out, okay, I isolate x1. Okay, so x1 equals 3 minus x2 plus x3 over the coefficient of x1 is 4. Okay, so put that note. And then put the iteration notation. So put K, put K. Okay, without the iteration notation, you will not get full mark. Okay, because normally the question asks for the formula first. Okay, construct or form the formula for x1, x2, x3. Okay, so without this iteration notation, you will not get the full mark. Okay, so please highlight that one. Okay, it is very important to have the iteration notation because that notation will differentiate whether you understand the Jacobi and Gauss-Seidel. Okay, the difference is at that notation. Okay, iteration notation. X2. Okay, X2 comes from equation number 2. Okay, equation number 2, at the right hand side you have 19 minus 2x1 minus x3. So put the K, over the coefficient of x2 is 7. Okay, and x3. x3, K plus 1. Formula for x3 comes from equation number 3, which is 31. Okay, so you just can refer to your notes. x1 plus 3x2 over the coefficient of x3. Okay, so look here, right? So 31 minus x1 plus, because you have the negative here, so plus 3x2. Okay, just rearrange your equation. Okay, plus minus here and there. Over the coefficient of x3 is 12. Alright, and then don't forget the iteration notation. Okay. Right, so those are 3 formulas for x1, x2, and x3. The given initial guess Okay, set. So this one here, okay, x naught at 0 equal to 0 is your initial value for x1, x2, x3. Okay, given in the form of vector here. So you can see the bold here, bold font style kat sini, meaning you have vector kat sini. Okay, so it is actually x1 not equal to 0, x2 not equal to 0, x3 not equal to 0. Okay, so I can have given x1, okay, not iteration or at iteration 0 lah, okay, equal to 0, x2 0 equal to 0, x3 0 equal to 0. So this initial value here depends on the problem. It is not always 0. Okay, sometimes a student too hurry in the test, in the exam, and you used to have the initial guess as 000 in the tutorial, in the exercise. You tend to write initial guess as always 0, okay, which is not. Okay, it is actually determined by the problem, given by the problem. Okay, so look carefully, highlight the information that you have, okay, from the problem. Okay, so that's all what we have. At the first place, you need to form the formula and state the given initial value. Okay, so now we start with the iteration. Okay, start with the calculation process. So I'm going to show you first the manual calculation. Okay, manual calculation. Always start with k equal to 0. Okay, so when k equal to 0, if we refer to equation for the x1, so at the left hand side you are going to have x1, 1. x1, okay, superscript 1. Okay, because k equal to 0. At the left hand side, okay, at the right hand side, it was the formula again, 3 minus x2 0 plus x3 0 over 4. Okay, so we know that x2 0 is 0, x3 0 is 0. So basically we have 3 over 4. So you have 0.75. Alright, and then now you can compute the error. Okay, error of x1. Okay, so I have x1 1 minus x1 0. Okay, so this is manual. Okay, manual calculation. So 0.75 minus the previous x1 value is 0. So the absolute error is 0.75. Okay, so it is greater than the given epsilon. Okay, the stopping condition is this one. Okay, so maybe I can put here. So add use 2 decimals je lah. Okay, in the exam it will be stated. Okay, so put that one. Use 2 decimal places in your calculation. Okay, so that is for the x1. And then you do the same thing for the x2. x2 1 equals, so refer to the formula. So you have 19 minus 2x1 0 minus x3 at the previous, which is 0 over 7. So again you have 19 minus 0 minus 0 over 7. Okay, so 19 over 7. This one, what's the value? 2.71. So the difference between two consecutive x2, so you have x2 1 minus x2 0. 2.71 minus 0. So 2.71. Okay, so still greater than epsilon, right? x3 1, by the formula, it is 31 minus x1 0 plus 3x2 0 over 12. Okay, so the two values, your initial, okay, x1 and x2 are 0. So basically you have 31 over 12. So this is 2.58. Also greater than epsilon. Okay, so basically to decide whether you need to proceed or stop, basically you refer to the error that you have, which is 0.75, 2.71, 2.58. So the maximum, okay, is 2.71 in this case. So this is way greater than 0.05. So, okay, so meaning that we need to proceed. Proceed with k equals 1. So you're repeating the same process. Okay, so manually it is time consuming. Okay, so you banyak buat calculation manually. Okay, so you can save your time, lot of your time, by using your calculator, because basically you are using the same three equations. You just change your x1 or x2 or x3. Okay, so you can speed up your calculation by using the calculator. Okay, so for the first iteration in the table, I can have, oh sorry, okay, based on your first iteration, basically you can have this table at the first place without manual calculation. Okay, I'll just give you the manual so that you have the idea how the values come from or where the values come from. So we start with a k. We need to start from here because we need to have many columns. K and then x1. Have your ruler. x2, x3. Okay, so that I just put here error, error x1, okay, error x2, or you can just have ex1, ex2, and ex3. Okay, so by the first iteration, always start with k equal to 0. So you put the initial that you have from the problem. So on the first line, you don't have the error yet. Okay, so back to manual calculation here. When k equal to 0, you have x11. Okay, meaning that you can fill in for, okay, in the table for k equals 1. Okay, so in this in the second row it should be 0.75 here, and then 2.71, 2.58. Okay, and all the error is supposed to be here, 2.7, 2.58. Okay, first iteration you should be able to fill in 2 rows in your table. Okay, so based on the error, the maximum is 2.75, meaning you cannot stop yet. Okay, so that you are supposed to have k equals 2 lah. Okay, so manually, when k equals 1, you should get x1, 2. Okay, so manually, you are going to have 3 minus x2, 1 now. Okay, plus x3, 1 over 4. Okay, refer to the formula for x1. But now you are changing your x2 and x3 values. Okay, because now you are going to have 3 minus x2 at the previous iteration. x21 is 2.71 plus x3 is now 2.58 over 4. So you are going to have different values now. Okay, so meaning that in order to have the value here, x1, 2 here, you will use the value in the previous iteration. Okay, you will have you need to have you need to use 0.75, 2.71, and 2.58. Okay, so with that we have 0.72. Okay, so 0.72. So you can see, okay, it is easier for you to check the error. Okay, you can see from the table, the error is basically the difference between these two. Okay, the difference between two consecutive. x. So 0.72 minus 0.75, so you can straight away put here, the error is 0.03. Okay? So the same process for the x2, you will have x2, 2. So now the formula is 19 minus 2x1. So I just put straight away here, x1 at the previous iteration, which is 0.75. So you put that value. Minus x3 is 2.5 over 7. So with this one, you have 2.13. Okay, in 2 decimal. 2.13. So you can compute straight away. 2.13 minus 2.71. So you get the error for x2. So the error here is 0.58. Is it? Okay, betul. 0.58. That's the error. Okay, so you can see error 1, error for the x1, you satisfy the condition. Okay, but somehow error 2, okay, error for x2 is still greater than the given epsilon. Okay, so you know that you need to proceed. Okay, but first you need to compute the x3 here. So x3 follows the same formula. So x3 equals 31 minus x1 now is 0.75 plus 3x2. x2 is 2.71 over 12. Okay, so you are going to have 3.20. So you put here 3.20. And the difference, 3.20 minus 2.58, 0.62. Okay, so you still need to proceed because the maximum of the error is this guy. Okay, so this one is the maximum. So this is way greater than the given epsilon. So you still need to proceed on the first iteration. So that one is the maximum, 2.71. Okay, so you repeat the process, okay, on and on until you satisfy the stopping condition. Okay, until the maximum out of the 3 errors that you have, that maximum value is less than 0.05. Okay, then you can stop. So for this one is actually, so I just give you the answer for now. Okay, after this we will do next exercise together. So this one is up to k equals 5. So the value is 2.00, 3.00. Okay, this one 0.01, 0.01, this also 0.01. Okay, so out of those 3, the maximum are the same. Okay, all of them are 0.01. Okay, but sometimes you can have like 0.01, 0.02, 0.03. So the maximum is 0.03. So already less than 0.05. So you may stop. Okay, but in this case, the maximum is exactly the same. Okay, so just put over there. Oh, habislah. Okay, I'm going to erase a bit here. Okay, so with that table, okay, so the maximum out of these 3 is 0.01. So this is less than 0.05, so we can stop now. Okay, but don't forget at the end you should write your final answer. So therefore x1 equals to the latest x that you have in your table, which is 1.01, comma. x2, the latest x that you have, 2.00, or basically 2. x3 equals 3. Okay, so that's, okay, I think the exact solution most likely 1, 2, and 3. Okay, but somehow because of round off during the calculation, so we might not get exact for the x1 here. That is 1.01. Okay, but that should be fine. Okay, so this is how you do Jacobi, how you apply the formula and also the stopping condition in the Jacobi method. Boleh faham tak ni? Jacobi. So
Boleh kata.
if okay, boleh. Alhamdulillah. Alright. So if you do not test for convergence at the first place, if you do not check for SDD here, meaning that so most likely you will use the wrong formula lah. Okay. If you do not change, you do not swap the arrows, the rows. Okay. Then your x1 is going to be 31 plus 3x2 minus 12x3. So different formula. Okay, and then you will see in your table, you will not satisfy. Okay, meaning that your error is getting bigger and so on. Okay, so sometimes students forgot to check for the SDD, proceed straight away with the formula, but then you will see in your calculation. Okay, then you need to go back to check the SDD. Alright, faham eh? Okay, try this one. Example 18. Solve the following system. Okay, so later, try and error for this because I'm going to proceed straight away to the Gauss ideal. But for this one, just change this to x. Not eh? So use this one. 2, 3, 5. I put the transpose here. Okay, so use that initial value and use only 2 decimal. Okay, because I've tested this one so many iterations, so I decided to cut down a little bit. So we change the initial value and also the decimal places. Use 2 decimal places. Okay. Okay, I try up to 5 iteration with the original initial guess, but I still cannot converge to the solution. Okay, so I don't have the final solution for this one yet. Okay, but just change to 2, 3, 5. Okay, and use 2 decimal places. Then if you use 2 decimal, change the stopping condition here to be 0.05. Okay, so try that one later. I hope not more than 6 iteration. Okay, normal number of iteration in the test normally 5 to 6 lah. Okay, for Jacobi and Gauss-Seidel. Okay, if you end up to 8, up to 10, then maybe you need to recheck back your calculation. Okay, that's on the Jacobi. Okay, now last one, the Gauss-Seidel. The same system. Okay, I want you to highlight the difference between Gauss-Seidel and Jacobi is here at the iteration notation. Okay, so that one. Okay. Okay, look at the formula here. Look at the first one. X1. Okay. So given the system, so I'm assuming here we have a system that is already have a SDD. Okay, so we assume this matrix A here is already the SDD matrix. Okay. So the first formula, which is X1, comes from equation number 1. Okay, equation number 1. So we have B1 minus A12 X2 minus A13 X3 over A11. So the first formula here is the same as Jacobi, the same one. Okay, so the difference start from the X2. X2 comes from formula number 2, equation number 2. Okay, without the iteration notation, it is basically the same as Jacobi. So it comes from B2 minus A21 X1 minus A23 X3 over A22. Okay, but in terms of iteration, for the X1, we already put K plus 1. But for the X3, it is still K. Okay, I'm going to show you the difference here. Okay, right. So look at this one. Okay, so you might want to have on a different paper, but I just refer to this. Okay, so I'm going to consider okay, so at the first place, you have the iteration initial gas 000. Okay. Okay, ya baik apa. Ataupun saya guna separate lah, senang sikit. Okay. Okay, this one is in Jacobi just now. You have K, you have X1, you have X2, you have X3. Okay, so at the first place you have 0, 0, 0, 0. Okay, that one given. Okay, so first by the formula, you will have the value of X1, 0.75. Okay, one is on Jacobi. Okay, but when you want to compute for the X2, so the formula for the X2 is, okay, in the Jacobi just now, you have 19 minus 2X1 minus X3 over 7. Okay, but in Gauss-Seidel, when you want to substitute the value of X1, okay, you immediately put 0.75. Okay, so when you compute X1, okay, just now, okay, it's still the same. So you have 0.75, the same as Jacobi. You're still using the previous value, meaning you use the value of X0, X2, 0, X3, so 0. So you come up with a 0.75. Okay, so you put here 0.75, which is at the current stage, okay, at the current iteration. So when you want to compute this guy here, X2 here, okay, this is by Gauss-Seidel, so you put 19 minus 2X1. So 2X1 here is the current X1 that you have in your calculation, the latest one. Okay, so you are not using X1 equal to 0 anymore. You are using X1 equal 0.75. Okay, so you put immediately the value that you have. Okay, the value that you have in your table. Okay, so far you have up to X1, which is 0.75 here. So in the calculation of X2, you need to use that value immediately. Okay, so you put 0.75 immediately. But for the X3, you don't have X3 at the current stage. You don't have X3 here yet. You don't have. Okay, so meaning that you need to use the previous X3 lah. So this one is still 0. Okay, faham So that's why in terms of notation, this is K plus 1 and this is still K in the Gauss-Seidel. Okay, so that's the difference between Gauss-Seidel and Jacobi. In Gauss-Seidel, it use the immediate values that you have in your calculation. So in terms of convergence, Gauss-Seidel supposed to converge faster compared to the Jacobi, because you update your values immediately. Okay, so that's the difference. Yeah, boleh faham tu? Gauss-Seidel. Ini pun sama. Alright, so ini. Okay, so that's why we have K plus 1 for the X1, but for the X3, you still have the notation K. Okay, iteration notation K. For the X3, you can see the iteration notation semua yang updated. Okay, you use K plus 1, you use K plus 1 for the X1 and also for the X2. Because, okay, by the time you compute the X3, you already compute your X1. You already compute your X2. Okay, so meaning that in your table, okay, so let's say somewhere here I can put just a random value. Let's say you have 0.81 here. Okay, when you compute your X2, okay, here somewhere. This is not valid, but Okay, just put any value for illustration. So when you want to compute your x3, so by the formula, it is 31 minus x1 plus 3x2 over 12. Okay, so for x1 here, you use the current, which is 0.75, but for the x2 here, you also use the current x2, which is 0.81. You are not using the previous values of x1 and x2. Okay, you substitute immediately the value that you have, okay, at the current stage. Okay, 0.75 and 0.81. That's why we denote this one as k plus 1, okay, iteration notation, and this is also k plus 1. Alright, so that's the difference, Gauss-Seidel and Jacobi. So the difference is at iteration notation. In terms of formula, there should be the same as Jacobi, except for iteration notation. Okay, initial gas also will be given same as Jacobi. Stopping condition, okay, the same one as Jacobi. Right? Okay, let's try one more, and then I think after that we are good to go. Okay, last one here. Let's do this together because I don't have the solution. Okay, this is it given? No, tak ada. Okay, example 19. Consider a linear system AX equals B. So this is actually taken from past exam, in the exam. A given, B is also given in terms of matrix yang kat sini, 9, 3, -6. Sometimes your system is given in terms of equation, okay, sometimes given in terms of matrix. Okay, you should be able to understand lah how do you read your equations, okay, given either in terms of table or in terms of equation. Okay, state the convergence criteria of A in order to be used for iteration method. One. State the convergence criteria for A. Just a statement here. No need to show anything, just in terms of statement. Okay, state the convergence criteria of A in order to be used for iterative method. Anyone? It is basically obvious.
A must be SSD.
Yeah. Yeah, in the test, write in full. If you write SDD, saya buat-buat tak faham je bila marking. Okay, so A must be, it's just a statement. Okay, must be a strictly diagonally dominant. Matrix. Okay, so number 2, what do we have? Number 2, write the Gauss-Seidel formula which satisfies the convergence criteria in 1. Okay, so this problem is actually to guide the student. Okay, as I've mentioned just now, sometimes students forgot to check for the convergence criteria. Straight away go to the formula. So we put at the first place, state the convergence criteria. Okay, hoping that student will aware that they should check for the convergence criteria. Okay, guideline to the student. Okay. So write the Gauss-Seidel formula which satisfies the convergence criteria in 1. Okay, so first of all, is A already SDD? Yes or no?
No.
Obvious, Di sini you look in terms of each row, okay, which coefficient is the largest. So you can see in the first row, the largest is 6, okay. So that is in second column, so it should be in the second row. Okay, so you know this is not true lah. This is not SDD initially. Okay, so rearrange. Okay, rearrange your A and B as well. Okay, so A equals, okay, so the first tadi akan jadi the second. So 2, 6, 1. Okay, and you look at the first column. Okay, which element, okay, is the largest in the first column. Okay, so 4, 4, -1, -1. Okay, so 4 is the greatest compared to the summation of 1 plus 1. So 4, -1, -1 should be at the top. Okay, -1, 1 and 7. So that's your A in the form of SDD matrix. Okay, so B need to be changed as well to the first one. Okay, so change accordingly lah. Okay, according to your A. 3, 9, -6. Okay, then the formula. The question asks for the formula. Very, very common mistake. Okay, in the test pun sama, in the exam pun sama. Student come out with this formula. Yang general ni. Ni saya tak nak ni. Okay, we want to have the formula that you are going to use in your next calculation, not in terms of B1, B2, B3, X12, X13, not in the general form macam ni, bukan. Okay, so whenever you see in the problem, write or form the Gauss-Seidel formula, okay, for a given problem, then put the correct coefficient lah. Okay, bukan dalam bentuk variable, bukan dalam bentuk elements of the matrix, A13, A23, A32, like this. Okay, so if you give the general formula macam ni, basically 0. Okay, for the formula, normally the mark is 2. Okay, 1 for the work, okay, kaedah, for the method, and another one for the correct equation. Okay, so if you give the general like this, 0. Okay, for that part, for the formula. Okay, if you give the correct coefficient, you put the correct value of B1, B2, B3, all the elements, all the coefficient of your X, okay, correct, but without the iteration notation. Okay, if you don't put the K dekat sini, superscript dekat sini, you don't put the K plus 1, K plus 1, K plus 1 tu, only 1 mark. You lose 1 mark for that. Okay, so you need to put the correct coefficient values, as well as the iteration notation. Okay, because that iteration notation, it differentiate whether it is Gauss-Seidel or Jacobi. Okay, in terms of equation, okay, they are the same. Okay, except for iteration notation. So please ingat benda tu, highlight benda tu. Hopefully, I'll not see that mistake again. Okay, so every semester I highlighted the common mistake, but yet there are still few students that repeat that mistake. Okay, so you might want to jot down or highlight in your lecture notes. So formula, the first formula comes from the first equation, so x1. So I put the x1, so don't forget k plus 1 dekat sini. Okay, very important. So k plus 1, x1, k plus 1 comes from first equation. So start with a b. So 3 minus 1. So plus x2. So this is still k plus x3. Okay. Over coefficient of x1, which is 4. Now x2 comes from equation number 2. x2 equals 9 minus 2x1. So this one is already k plus 1. Don't forget that one. Okay. Iteration. Updated iteration. Notation. Minus x3. Still k here. Over 6. Lastly, k plus 1. x3 k plus 1. -6 plus x1 K plus 1 dah dekat sini minus X2 dekat sini is already K plus 1 over 7. So dapatlah 2 marks for this. Right. Okay, now form your table. Buat cantik. Now we are going to use the calculator straight away. So get ready with your calculator. So we have K. So I put the X1 here. This is actually X1K. This is X2, K, X3. Okay, so I put E for the error. Error X1. Okay. Error X2. Error X3. Okay, what's the problem? Use 3 decimal. So highlight. Do your calculation in 3 decimal places, and the initial value 0, 0, 0. Stopping condition 0.005. Okay. So K equal to 0 at the first place. K equal to 0. The initial is 0, 0, 0. So for the error, you don't have yet. Okay. Now, let's use the calculator. I need to share my calculator first. Tak nampak ke? Okay. Apa ni setup? Okay, that's the calculator and our table. Okay, so you can see we have 3 formula. So we are going to store the formula in the calculator. Okay, so you have X1, X2, X3 to be used. Okay, but in the calculator you don't have X1, X subscript. You don't have that form in your calculator. So we are going to represent X1 as A in the calculator, X2 is B, and then X3 is C. So you should know that. Let's stop the video there. Okay, so that's on your calculator. Okay, meaning that the first one we want to store in your calculator. So I put here. In your calculator, the first formula that we want to store is 3 plus B minus plus C over 4, the first one. Okay, second equation that we want to store is 9 minus 2A minus B over 6. 3. Third equation is negative 6 plus A minus B over 7. Okay, so we put one by one. Okay, so the first one, we have 3. So alpha B, sorry, plus alpha B plus alpha C over 4. Press equal. Okay. Then press AC. So it is already stored in your calculator. Equation number 2. So put 9 minus 2A minus B over 6. Pada equal. Okay. AC. Lastly, negative 6 plus A minus B over 7 equal AC. Okay, now when K equal to 0, so on the table we have 0, 0, 0. Alright, so now when K equals 1. Okay, so in the first place, okay, we want to have the formula 1. Okay, so you are going to compute x1, 1, which is actually in the manual calculation when K equal to 0. So you have x1, 1 equals 3 plus x2. Okay, so the value of x2, which is your B in the calculator, okay, is 0. Okay, so we are going to recall equation 1. So use the arrow button here. So this is the third one, second one, this is the first one. Okay, so use the calculate button. So the question will, the calculator will ask what is your value of B that you want to use. Okay, so for now, the value of B still 0. B refers to your x2 lah, okay, in your table. So B is 0. What is C? C is also 0. Okay, so we have 3 over 4. Okay, so in terms of decimal, 0.75. So we put here 0.75 straight away. In fact, for the error, you can straight away put 0.75 because minus with a 0. Okay, now you want to compute now for the x2. So recall formula for x2. Not this one, not this one. Okay, this one. Okay, 9 minus 2a minus b. So use the calculate button. But now the calculator will ask what is your a. So in Jacobi, you will put a equal to 0, the previous one. But in Gauss Seidel now, you are going to put the latest a that you have. A refers to your x1. So in your table, you already have your x1 at the current stage. So your x1 is 0.75. So you put 0.75 immediately. Okay. And what is the B? B is your x2. You don't have B at the current stage yet, meaning that you need to put the previous B lah, which is 0. So you put 0. So 5 over 4, 1.25.
Doktor,
Yeah.
bukan C ke? 9 tolak 2A tolak C. Saya salah.
Betul, betul. Betul, saya salah. Okay. We have one more. Wrong formula for the second one. So I hope you do the correct one on your own, on your formula, your calculator. Yang 1 dengan 3 betul this one, number 6. Okay, never mind. Okay, try lagi sekali. Okay, calculate the A, x1 is 0.75, so sama, 0.75. Okay, so C is 0. Okay, the previous one. Okay, so we have 5 over 4, so 1.25. So here, your x2 is 1.25. Okay, now, look for the x3. x3 comes from equation number 3 here, negative 6 plus x1 minus x2 over 7. So we find the, this one, okay, this one. Ni betul A and B, alright. So now use the calculate button. Okay, the calculator asks what is your A. A is at the current stage, which is 0.75 in your calculator. What is B? B is now your current B, your current x2, which you already obtained just now, 1.25. So you put immediately 1.25. Okay? So you get negative 13, blah blah, which is negative, tadi saya suruh guna 3 decimal 0.929. Okay, So in terms of error, so this is 1.25, this is 0.929. Alright. So the maximum error, is 1.25. Okay, so 1.25 is way greater than the given epsilon. So meaning that you need to proceed further. Okay, meaning that you need to proceed to k equals 2. So you are recalling for the first formula x1, not this one. Ini okay. So put the calculate and press the calculate button. Okay, so what is your B? B is 1.25. Okay, you don't have the current B yet. You don't have the current x2 yet. So it should be taken from the previous lah. 1.25 here equals, okay, how about the C? C is also from the previous one, which is negative 0.929. Okay, so this is your x1. Decimal. Okay, compute for the x2. Call for x2, this one. C, mana C? Okay, calculate button. Now your A is already changed. Okay, your A is not 0.75 anymore, but it is 0.83. Okay, the latest one. Okay, you put immediately your A, but C still taken from the previous one. Okay, so C sama. So you have 1.378. Okay. Okay. In fact, after you have computed your x1 and x2, basically you can straight away compute the error. For example, for this one, 1.378, you can minus with the previous one immediately, 1.25. So the error is should be at x2. So this one is 0.128, the error. Okay. When you want to use the formula again, so you just press the calculate button, the arrow button over here. Okay, this one for x3. So x3, the current x is 0.83. Okay, B is also need to be updated, 378. Okay, so you have, what is this? Negative 0.935. So you can check the error as well. Okay. Okay, please proceed. Nanti saya minta je ni from anyone. Berapa? Okay. Okay, proceed with the calculation. X1. Okay, saya panggil. So put your answer in the chat so that I can see. Okay, buat dulu. This one, error 1 is 0.08. Error 3. Okay, row number 4. K equals 3. What is X1? Rahman, ada answer? Do you have X1? Moment 0.86. Okay. Anyone can confirm?
Dapat 0.86.
Okay. So I just put here. 60. Okay, X2. 1.369. Amir Nasiruddin. Johan, boleh confirmkan? Johan, the value of X2. Mana-mana Johan lah. Ada berapa Johan? 2 Johan. Is it 1.369? Saya tak kira ni. I rely on your answer. Okay, moment. 1.369. X3. Sekejap. Panggil sekejap. Hafiz? Hafiz, do you have for X3? Negative 0.93. Betul? Alright. Kalau ada yang lain sangat too much different, okay, please cakap kita check. So error I think not satisfied yet. Okay, macam besar lagi tu. K equals 4. Okay, kira dulu. Cuba takkan error. Proceed. .03 satisfy, but let's see the second one. And 009 satisfy already. No? Stopping condition 0.005. Okay. So the maximum is 0.03. Okay. Still need to proceed. So X14. Luqman, ada jawapan? X14. Luqman, ada tak Luqman? Luqman ni Luqman tak ada. Sampaikan salam sayang saya dekat Luqman. Okay. Luqman tidur, most likely. Ya, mana kena Luqman ni? Siap dia nanti. Farah. Farah Arisha.
Yes,
Yeah, X14. What's your answer?
I've got 0.86.
X6. Moment 859. So I think acceptable lah. Okay, because most likely because of the round off. Okay. If we have 0.86 Okay, so saya pakai yang Farah punya. Okay. So the error obviously 0 already here. 0.000, basically 0 je lah. Okay, X2 for ideal. Do we have ideal? X2 for ideal tak ada juga. Kawan-kawan nak menyelamatkan ni. Ideal makan. Oh, seronok dia. Untung dia boleh makan. 3, 6, 8. Aidil. 1.368. Kira ke tu? X3, X3 for apa lagi belum? Banyak lelaki je. Anas. Anas, X3 4. Mana Anas? Negative 9.3. Anyone can confirm? So most likely, okay, negative 0.93. Sama, yes, okay, good. So it means now, so the error is 0. For the second one, 0.001 lah. Okay, so seems like we already satisfied the condition, the stopping condition. Okay, so we can see now the maximum, okay, maximum error is this one now. Okay, the previous one, it is 0.03, so you still proceed. This one, 0.128. Okay, so for the error here, just write a little bit. Okay, the maximum error, okay, maximum 0 in terms of absolute, so you look for in terms of absolute error. Okay, equals 0.001, which is less than the given stopping condition, that one. Okay, so we may stop now. Don't forget the final answer. Therefore, x1 is approximated to the latest x1 that you have in your table. So x1 equals 0.860. X2 is 1.368, and then X3 equals negative 0.930. Okay, so that's your answer. Okay, at the first place, you can check your answer using your calculator. So put this system, okay, put all the coefficients here in your calculator. So check for the exact solution. Okay, mine. Okay, suppose not this exact value here, not this values, okay, because this is approximation. Okay, plus you round off to 3 decimal. Okay, your calculator gives you the exact solution, the actual solution as a guideline for you. Okay, so that you can check, okay, whether it is too much different. Let's say you have x1 is 2 point something, for example, then you will need to check back your calculation. Okay, so of course when you put the value of x1, x2, x3 in your equation here, you will not get exactly 3, 9 and negative 6 at the right hand side. Okay, but it should be around that. Okay, that's the error. Okay, any problem on the Gauss-Seidel and also the Jacobi? Normally in the exam, either one lah. The question will ask either Jacobi or Gauss-Seidel. Okay, not both of them. Okay, you faham the difference there? So I think that's all for now. Let's conclude chapter 2 as well. Okay, so for mana saya punya tak pergi. Sekejap, I'm losing the button. Okay, dah. Okay, any problem on these two methods or anything that you have inquiries for chapter 2? Okay, this is the end of chapter 2. Next week we are going to discuss interpolation and curve fitting in chapter 3. Tak ada soalan Tak ada. Okay, another homework for this weekend. Okay, inshallah I'll put by tomorrow, inshallah. Okay, please turn on your notification of Google Classroom. Kenapa tu? Is that Idris? Why are you sad? Kenapa? Okay, homework I'm going to give you homework dalam Google Classroom, and then dia nak homework banyak lagi, okay boleh je, tak ada masalah. And lagi I'm going to start focusing on test 1 okay, you are going to have your test 1 less than 4 weeks from now, less than 4 weeks. So start do exercises, okay, road to test 1, okay, kita buat hashtag road to test 1. Okay, so we are going to have quizzes, exercise, okay, homework tu macam biasalah every weekend for the homework, and quiz I'll post the corresponding dates lah for your quiz, okay, later. Quiz 1 for chapter 1, maybe together with chapter 2 as well lah. Okay, so once you scan this, then you can leave the room. Okay, kalau tak ada soalan, that's all for now. Thank you everyone. Assalamualaikum.